My name is Paul Way. I am the computer science teacher and upper school technology coordinator, and now apparently the scheduler for Crossroads Upper School in Santa Monica. We are a K-12 independent school. I've been there for about 16 years and taught a year-long course on a fall, and it'll be interesting to see how much of the curriculum ports over and how much will be completely new as we get started in the fall. Matt, do you want to jump in?
Yeah, so I'm Matt Johnson. I am a high school physics and artificial intelligence teacher. Um, this is my 12th year as a teacher, and it's my 5th year teaching an artificial intelligence class. That is the completer course in a sequence after AP Computer Science Principles. I do have a background in AI, master's degree in the subject, but I mean, then I went to industry and then I went back into academia. So to say that things are going forward fast is an understatement. So there's so many of the new things that I may understand the foundations of, but that doesn't mean I know how to do all those details. Further, in terms of pinning down a curriculum for an AI class, it's just evolving so fast. Like I say, my other area is physics. It's pretty stable. But the AI, I mean, even if you think you have the perfect course, I mean, at the beginning of the school year, ChatGPT didn't exist. So what do you do with that? You just have to keep on adapting. All right, so let me set the stage just a little bit here. This slideshow you're seeing is one specifically for today. As we click through, we have some links. We have the one for the in-class deck that's going to chop out some of the things that are really just for you all. We have an educator guide that is some documentation, help you explain things a little bit and see where things are going. The actual technical part of this is going to be from the site Replit. And so we have links to that Replit here, as well as, Paul, you put it up on GitHub too, right?
Okay. I did, yes.
So those are all links that you will have, but this slide is not included in the one that you'll use in class. Learning about the attention mechanism with pop music lyrics. And you've already met us, but that's Bitmoji us. So hopefully you like us as much as our Bitmojis. Okay, so goals for today for the faculty meeting. Broad understanding of AI, language models, specifically the attention mechanism. Leave with the lesson tools and ideas for teaching AI and connect with other educators. We will have time for questions at the end, but you can also ask questions at any point. So this is meant to be something, particularly with such a small group, that it can be interactive, and parts of it that you're confused by, please do ask questions. Okay, so the essential question here to keep in your mind is, how do context clues help us predict the next word in a sentence? Because that is how generative tools like ChatGPT are working. So this is the main thing to be in mind. We're not going to get a complete understanding of this stuff today, but it is something we were inspired by ChatGPT and the attention mechanism and trying to get students some intuition into how this is all working. Okay, Paul, can you take the big ideas?
Yeah, absolutely. I think as we walk our way through this lesson, part of our goal, as Emily was referencing earlier, is to kind of demystify this and just make more clear to students that this, these large language models are not some all-seeing eye in the clouds. This is under the hood. This is math. This is making predictions. And because it is making predictions based on testing data, it's going to be wrong sometimes. And we need to be aware of this as AI works its way into more and more aspects of things seen and unseen in our lives. So, we're going to look at how this uses predictive modeling to generate the next word here, but obviously that applies to the next pixel in an image or note in a song. We're going to look at how we're looking at kind of context, and we're using the word attention. For those of you who have a CS background or may have read the 2017 paper, Attention is Everything, that was a bit of some of the inspiration to what we're looking at here. And then, you know, for our students, we're hoping that they come out of this with this idea that there's going to be randomness in this for good or for ill, and that we go through phases of training and testing with our modeling process.
Right. Okay, so this begins the part where we would be starting things out with the students. So starting them off with something to discuss right from the beginning. So we have a sentence, and if you like a different sentence, you can absolutely use that. Complete the following incomplete sentence. At the zoo, we saw a, if you wouldn't mind, can you just type something in the chat? What would you say? At the zoo, we saw a, all right. I see monkey, panda, zebra. Makes sense. So then what we would have the students discuss is, all right, what word do you say that comes next? And of course, they're probably going to pick different types of animals, but not the same one. And then how do you draw that conclusion, right? So where they go with it in the discussion, of course, this is part of the improvisational part of teaching. But with the context clue of zoo, we're immediately thinking probably of, okay, what kind of animals are going to be there? So we would look at the various words, and the words that are most important, these are the ones that essentially we would say we would pay the most attention to. All right. Now, that's something of a hook and an intro part. The next part kind of is too, and it's something that'll take a little bit longer. So I might cut it a little bit short. And of course, you could cut it out entirely if you needed to. An experiment. All right, some of you may have already seen this. So I'm going to play the video, and I want you to just follow the instructions on it. I don't know if you've seen this before. This is something coming from the field of cognitive psychology. And this is where the idea of attention comes from. In cognitive science, in neuroscience, they're focused on this idea of attention and the recognition that we clearly pay attention to some things more than others. We can't pay equal attention to everything. No. All right. So the Invisible Gorilla and Selective Attention, it was run by Experiment Simons and Chibri in 1999. It's supposed to show what we pay attention to, we notice, and what we don't, we may miss. Incidentally, based on their original studies, they said about half the people who watched this saw the gorilla. So it's not like it fools everybody. And so if it didn't fool you, then that's okay. That's part of the thing. I will tell you, the first time I saw it, it totally fooled me. I was just super focused on counting everything, and I did not even notice the gorilla. So it may not have tricked you, but it'll trick some people. I don't know. I kind of have a feeling younger students today might be better at it. But either way, it's a thing where if you're focused enough on the task at hand, you're not going to see the gorilla. Like, you really are just going to focus in on what you're asked to do, and something really obvious you can miss. There are variations of this that you can look up if you don't like that video that are maybe a little bit more subtle. But of course, the fact that this is not subtle is part of the appeal to my mind, since I got tricked by it. All right, so now that's a time for discussion. So it doesn't seem like it's a good thing that we can miss important cues that we weren't looking for to pay attention to. So what's the benefit of selective attention? All right. And of course, if you want to say some things, you can, if you want to ask questions. But the essence of it is we do not have the ability with our brains, as powerful as they are, to pay maximum attention to everything. So we have to choose what we pay attention to. And our ability to choose what to pay attention to is actually incredibly important. It's an essential part of how our brain works. And anything that's based on how our brain works is something for us to consider using in artificial intelligence. And so that was the inspiration behind what we now call the attention mechanism in artificial intelligence. So from psychology to AI, attention was just what we needed. All right, so highlighting two papers here. And of course, if you have an advanced class, each of these could be a lesson that everybody like goes and reads these because these are publicly available. We would not expect high school students to be able to understand everything that's in there. This is the first of the two, called Neural Machine Translation by Jointly Learning to Align and Translate. If you actually look at the paper, you'll see that they only mention the word attention a few times. But the idea of it is what really caught on from the paper. So the decoder decides parts of the source sentence to pay attention to, right? I will say in the activity that we've designed, the students are going to take the role of the attention mechanism because humans are already good at this. And coding it up, well, that's something that takes quite a lot of backgrounds, more than we can expect to do at the high school level. Okay, so I've got a couple more slides here on the attention mechanism. To illustrate what we're seeing here on this, we're seeing a sentence broken down word by word in columns. There are 4 columns. I can't actually see the 4th column on my machine right now because I see all your beautiful faces. But the essence of it is we're focusing first on the first 2 columns and the word it's in gray. And the thing is, it's is a pronoun, and pronouns are super confusing, right? If you just come into a conversation and people are using pronouns, you may not know what they're talking about because they are using them as a shortcut for stuff that they've already said. So we need, in order to process language, we need to have a mechanism that can look at things like pronouns and say like, okay, but what does it refer to? How can I possibly predict what I should say next if I don't know what it means? Right? So in this particular case, there's 2 things that get highlighted: the law and application. So what is it's? The law. And what is it referring to? Well, the next word is application. And when you look at the 2 columns to the right, what you're seeing is basically all sorts of connections, right? Because all of these words are connected to other words to various degrees. The art of how you get an algorithm to actually do this effectively, again, more complexity than we're getting into at the high school level. But our brain does this, so we can have our students do this part for us as we're providing the rest of the context. But this is still complicated, so feel free to ask questions. I can't give all the answers in this context, and frankly, I'm still trying to get my head completely around what's going on in ChatGPT myself. So I'll do my best, but we're all struggling with it. All right, continuing on. Okay, so transformers use attention to generate the next word and the next and the next and the next. So the other paper was 2014. This next one, Attention is All You Need, comes in 2017. Again, as a physicist, I'm blown away by like how recent all of this stuff is. So we propose a new simple network architecture, the transformer, based solely on attention mechanisms, dispensing with recurrence and convolutions entirely. So essentially what they're looking to do is cut out the time complexity that we don't need in order to do this and come up with a new algorithm that is parallelizable, which means it'll work with GPUs. Notice that while they call their architecture transformers, and that's what everybody's talking about, I mean, the real epiphany that they had, the real thing they were trying to do is just, can we use the attention mechanism for all sorts of things? And they just didn't want to call their their architecture, like the attention architecture, they named it Transformer. Um, it's not an inaccurate name, but it is kind of vague. Honestly, it's one of those things where if there wasn't a blockbuster movie series named Transformers, I think it probably gets another name. Whereas attention is something that comes straight out of the cognitive science. All right. So this is not something that I'm looking to explain in detail, but suffice it to say that when we look at the bottom, we see the input and we see the various words. And the thing about these transformers is they're not just processing them one word at a time. They're processing all of them and they're going through this step so that they can be used in the transformer. So we have things like position embeddings, token embeddings. These are ways that we represent this data, and we can find good videos on YouTube if you want to go through it in more detail, but suffice it to say, it selects the next word, and then that word becomes part of the input, and that helps choose the next word and the next. And if you played with ChatGPT, you know that, I mean, there's no limits to how long this can be. So I just showed one here that I was playing with that I found particularly fun. Pretend you're a dog and explain oxytocin. Woof, woof. Oxytocin is a hormone that dogs release when we feel happy. I won't read the whole thing, but I loved it just because, like, I mean, it went beyond what I was saying, but everything that it said was actually really appropriate and taking the perspective of a dog. Now, I have two dogs. I would love to totally get inside their head. I don't think this is a perfect approximation, but it is fun. And you can do a whole bunch of other things along these lines. All right. All right, Paul, I'm going to hand it over to you.
All right. Sounds good. If you want to share your screen, I'm going to jump in, and I am also going to, if I can here, I'm going to hit enter and send in the chat a couple of resources. I realize I'm not sure if you all have access to our slide deck, which is shown. And then the REPL link with the activity that we're going to dive into is also linked in the chat there. Let me go ahead and screen share. And we will get started. So based on the activity or based on the ideas that Matt has been outlining for us, I put together a REPL where students could kind of sandbox and try out some of these ideas. And full disclosure, I'm a pretty bad JavaScript and CSS developer. And so most of this was put together in a weekend with the help of ChatGPT, both for the text that you are seeing here and also for the underlying code, asking for it to write specific functions, and kind of grabbing the output, which was hugely helpful. So for students, the idea here is that we would ask them to kind of step through and walk through the introduction a little bit, and then train a bit of a model. So I'm actually going to start with Taylor Swift here. And the idea here being, can we guess the last word in this line? Any Swifties here want to shout out and help me out with what they think this is going to be? No Swifties here. That's okay. I'm going to help you guys out. Take a look what you've done, because baby, now we got bad blood. So as we type in our word, or if we need to hit the reveal button, we're going to get some options for what words were most crucial in deciding what came next. Well, blood kind of is used in this case to rhyme with done. And the song name is Bad Blood. So I'm going to choose those two words as being crucial to understanding that the output in this case, the line to, or the word to fill in the blank in the line, should have been blood. I'm going to jump on to the next one. He's so tall and handsome as hell. He's so bad, but he does it so.
Well,
So, thank you. Thank you. So, well is my correct word here. And I'm going to just choose a couple of the words that I think are influential here. And you'll notice we're storing this in our model down at the bottom. The computer scientists that are here today, y'all probably recognize this is actually essentially a dictionary where these would be the keys and these are stored as kind of like things we're checking. So I'm gonna give you all a chance to go through and try some lyrics using the REPL link for 1 minute. And then we're gonna loop through and just look at some of the review questions that I hope may be the things that we're hoping to direct students for. So you have 30 seconds, 45 seconds, explore, see if you can jump in and try out some lyrics. And then we're going to jump onto the second tab and look at the evaluation and maybe some of the questions that we might have for students there. Okay, so hopefully you all had a little bit of chance to interact with this, and I will just say, please excuse, like I said, my poor JavaScript programming. But on the evaluation tab, hopefully at a certain point you get to the point where you have some type of model, some type of set of rules that you can use to evaluate. Like in this case, what I would want to draw students' attention to would be that in the first set of lyrics, we said, okay, well, it's definitely, if we see done and bad, that means the missing lyric is blood. Well, guess what? We actually also might have seen bad in the second sentence, calling out that when we deal with large language models, what we are looking at is kind of a probability that a next word might be filled in. And out of all the available choices, large language models work by kind of dialing the knobs of how likely they think a particular outcome may be. The other things to think about here is obviously we only had a very few sets of examples and sets of lyrics. We might do a little bit, we might have a whole lot more of Taylor Swift's catalog or, you know, Frank Ocean's catalog to analyze here. And in AI, of course, more data is a better outcome. And I think the other thing that I would want to call students' attention to here is that for us in this example, it's pretty easy to get a view into what's going on in the model. We can see these are the words we're looking for. We can see that 100% of them were found in the lyric. So we know how the model achieved its answer. When it comes to other large neural networks and large models, we don't have that level of visibility. And there will always be unintended hidden things lying in wait when we have, you know, millions of parameters that we are dealing with in the model. So in the last tab, we look at testing, and this kind of gives us an opportunity to talk about, well, if we train our data on Taylor Swift, it's going to be awfully bad when it comes to Bruno Mars. And in fact, yes, all of the lyrics that it would suggest for Taylor Swift, should have brought you flowers and held your man. Okay, that rhymes. Not exactly the right line. But this, again, I think provides an opportunity to talk about ideas of making sure that your training and testing data are alike and how that can be really difficult in the real world. And talk about, you know, kind of things that you might be able to do to make a model better. So on our slide deck, we have a couple of these questions for reflection as we go in. Things like, you know, getting students to really think about what made a difference in predicting the next words, what the models might do well for, how you might improve the model's performance. And it's an opportunity as well to talk about things like what happens when you have uh, new work that gets created by the help of an AI. And it was based on the work of an artist who is not getting paid, isn't credited, and yet was a huge influence on the work itself. Those are questions that we really don't have answers to as a society quite yet, but I think are pressingly relevant for students. And I think they will be eager to dive into and discuss those issues as well. I think that is all I would say from the activity there. I do think there are a couple of possible extensions here. I think obviously this is not a perfect, this is not what a large language model is by any means. This is a stretch, and it's a bit of a convoluted use case, but I think it touches on some interesting key ideas and provides some opportunities for diving into this with students. There's any number of ways to remix this, and I please encourage that. The REPL can be forked really easily, and the data all lives, in fact, in a separate file in the lyrics file where you just have the name of the artist and then a comma-separated list of their lyrics, which could, of course, be lines from Shakespeare or famous speeches or what have you. I think creating a mashup of artists that could turn into essentially a lyric Mad Libs could be a fun extension for students to try and build here in code as well. So our questions for you all, opening it up, would be thoughts, feedback, ideas for extension, and what of this resonates?
I think it's fun for students to try different like word selections, and then they can also talk about the reason. So I think this can be used in the language course, and even good for ELD class, which you can choose based on the student's background, or maybe choose singer from different places. And is it possible to put in other singers or okay?
Yeah.
So
you got the HTML.
Okay,
yeah.
That's cool.
Yeah, what comes to mind for me is, I'm sure we all watch Fallon, where he has that game, right? Where basically he has an artist come up and say, all right, sing this Drake song in ragtime, right? And so you play that game. And so you can do that where you have them rap the lyrics, right? Especially if you've got rap artists. And you go put a beat out there and have them do this and have them do it after they do this, because I think that'll bring up the engagement level when they start rapping, because anything like that. And so I love the music idea. It really will bring out more engagement, and then say, okay, do Drake as if he were 50 Cent, and how would the lyrics change, right? And like, okay, keep the swearing down.
Yeah, Lil Wayne was not going to be in my first set
not in that group. Yes, that's why you kept it with the Swifties. I know.
I tell you what, it's perpetually a frustration for me, because I do like a song of the day at the beginning of the period, and I get student requests, and it's just like, it's so hard to do rap because there's so much swearing. So like, if you're familiar with Drake, you know that I'm like specifically like, okay, what can I put in here? What can I not put in here? Am I sure I know what this means?
Yeah, that's
right,
code
this
for
isn't some
something
drug
else.
reference, is it? Yeah.
Yeah, I try to keep it with Harry Styles myself, and they're like, "Oh, your music is so cringe, Mr. Butler," and I'm like, "Well, it's clean at least."
That does bring up something that I meant to plug in this workshop as well. The field of CS has a known diversity problem. And one of the things that was in the back of my mind when designing this lesson also was the Universal Design for Learning framework. I don't know if any of you all have come across that, but it's a framework that kind of looks at like, how do we take a lesson? How do we make this more accessible to people who might be underrepresented in that field? And one of the things right off the top is, if they can have some agency and choice, if they can choose it's this artist I'm interested in, or I'm going to actually forget all of these. I want to actually put in an artist of my own choosing. Right off the bat, there's a little bit more buy-in, there's a little bit more investment. And I'm going to see if I can dig up and drop a link to that framework in the chat in case that has not come up.
So that means you got to go solicit them a week in advance. You can prep over the weekend and pull in the proper lyrics and bleep out the bad ones.
Could
Yeah,
be,
or I mean, they could just get access to the code themselves, their own
Yeah, you
fork
could
of
have
the
them
code,
edit. Sure.
right? And edit those things. Now, I mean, if they're sharing with other people, then we may want to check and see exactly what they're putting in. But yeah, I think there's a lot of opportunity in this for students who are ready to expand what's already there. And as we talk about choosing music, I mean, the way that my administration tends to talk about it is voice and choice. What can we do to add relevance? Well, if you give them more say in it, it really helps.
Mm-hmm. Agreed.
All right. Do y'all have more questions? I mean, you can certainly give feedback. It can be specifically on this topic, or it could be on
So
something
did
more
you guys?
broad.
Yeah. So is it part of the algorithm, or did you guys purposely leave out any math?
it is actually the math. What it does currently is all it does is compute percentages for the number of words found. I think I didn't.
But then
quite
there's going to be a
implement
selection
this.
process, right? That says,
Exactly.
okay, my highest choice is, and there's got to be a factor that says, okay, you beat the 85% threshold, and therefore you are the next word. Something.
Yeah, I agree. And I didn't actually implement that in the code. And there's a great opportunity for remixing this in that way to show like the line with based on the model what the word would have been. And to be honest, that's gonna be a hook for a lot of students as well, to be like, wow, mixing Frank Ocean and Drake comes up with some really crazy stuff. Check this out. And I agree. I think that that's a wonderful opportunity for extension for students to write a function that implements that.
Okay, so they could write the bad lyrics, right? They could put in every word, right? Just say, okay, this is that. Sing the song, bad word. Sing the song, bad word. Sing the song, bad word. Sing this one. Oh, it actually works. Okay, that's one, right? And then go through the rest of the list. Now you got 3 contenders for your lyric for that line. How do we select that? So you walk them through that. Okay.
There definitely could be some fun there. And I mean, the way I would implement it would be something like pull the keys from the dictionary that you had of your training data. Then, based on the probabilistic models of like what the words were found in it, add that all up together, get a random number generator to pick a number. If it's, depending on the range, it would choose that word.
Okay.
If that pseudocode makes any sense.
Yeah, that makes sense. Next thing that people are generally interested in, at least in my, is Wordle. I used to do Wordle Wednesdays, and I say, okay, 1, it's cross-curricular. 2, it's usually a different part of their brain. It's a little bit of a brain break, and they really get into it because I award points for just playing, right? I want them to be doing something different, because a lot of times they're like, well, I got a math quiz, and they're studying for their math instead. And so I do Wordle Wednesday and turn it in, and we'll see who gets prizes for that. And so I'm just wondering if there's a flavor of what you're just talking about for Wordle.
That's I'll have to think about that one. That's an interesting idea. I honestly usually do the Wordle every morning with my daughter on the couch, and it's maybe the highlight of my day. It usually all goes downhill from there.
Well, at least you have one. At least you have. Most of us, we have our coffee and we dread. How many more weeks before summer?
Well, I am going to, if there isn't anything else, I'm just going to put another link to the feedback form in here. Matt, do you have any other closing words yourself, sir?
Yeah, I mean, one thing I was going to mention is something that we kind of bandied about as we were thinking about ideas for this. And I mean, tangent on that, like, I really appreciate you guys being here. This is a nascent community. This is people with some backgrounds, but of course, we're all figuring things out. And so we encourage you to get involved with AI for CA, and we'll be figuring out new things as they come along together. But one of the things that we had discussed as a possibility was doing something with, there's a variation of Wordle called Semantle. And there's a couple other games that exist that are all about making use of semantic connections between words using things like Word2Vec and other things along those lines. So that's something that could potentially be joined in with something like this, because when we are talking about this attention situation, part of what we're talking about is a semantic understanding. But we didn't include it because in the end, I mean, it's easy for an exercise like this to become just vast. And we weren't prepared to give you like a week-long unit on this. We wanted to keep it down to one lesson. And we thought that this was the thing that was our best bet.
Okay. And then I guess for the advanced students, they probably want something. So I'm going to throw that out for your future thought. Is obviously we all know there's a conversion process, changing words into numbers, because everything's basically a binary value. And so you could talk, if you could talk to the vectors instead of words, right? So every word has a token, right, if you will, and then you do the correlation that way. But it's faster, especially if you want to implement it with the GPU, right? You don't necessarily want to do the parsing of the letters. You want to actually just have a vector, and build that table that way. It's faster, right? That's what I'm saying.
Yeah, and I definitely think there is room for a high school AI lesson that really focuses on that word to vector conversion, putting these things into numbers, having them understand how these algorithms can work.
Yeah. And then back to the, I guess, way back, and this probably makes no sense because I'm thinking about it, is Huffman code encoding, decoding, right? Fax machines. It's like, okay, what are we trying to do, right? We're trying to compress all these bits and get it across this very antiquated communication system called the telephone system. How do we do that efficiently and get, because we're getting, luckily we're in the world where we've got gigabit downloads, right? I mean, megabit downloads. But if you try to push this over ancient technology, let's say you try to take this to someplace that's more primitive, how do you make this work? Because you don't have the bandwidth, right? That type of thing. Because right now it works because we've got lots of CPUs, we've got lots of GPUs, we can multi-process, right? But what happens when you're resource constrained? How can you still make the algorithm work?
Oh, absolutely. And I mean, I think it's interesting because, I mean, traditional computer science education is so focused on efficiency, and we've kind of gone away from it because our machines are so powerful nowadays. But I mean, the whole thing with transformers is, yeah, it's still biting us. When we're using recurrent neural networks, we need to process things faster. And so we are still doing these things, but it's on a more advanced level. So I do think that what you're describing in terms of some basic algorithmic thinking, I think that would be a great thing to expose them to as they understand the benefits of parallelization.
Yeah, that'd be more like a junior senior level course as opposed to what you're doing right now. I think it's great for just the introductory as to how does this thing work, right? Give them a feel for how do we fit it, just like we do, right? And we all do that. Especially, I know I get at the end of the day, my brain loses it, and I'm like fishing for a word that to complete the sentence. And you're like, I got the big word. I know what the little word is, but I'm looking for the big word because it's more accurate as to what I'm trying to feel. But I'm like, I'm searching. Never mind.
Before we get out of here, there's one thing I kind of want to call out that Monica, I think I'm sorry, Miriam, you referenced early on that it is very much in the back of my mind here, which is this is a transformational tool. Our students are leaping on this. How do we manage school policy around this? And how do we mitigate the downsides of this with our students? And I think in a sense, that is not what the focus, this event was focused on. What's our responsibility to meet the moment in teaching about these things to students. I think there is a separate but parallel imperative to get as many teachers using these tools quickly as we can. And both Matt and I are kind of talking about how we can do initiatives within our, institutions to do exactly that, to get a bunch of teachers actually getting their hands on these tools, playing, trying things out as fast as possible, and then having conversations with our school administrators to put policy in place.
Yeah. Thank you
Yeah.
so much. Yeah, it's really,
Oh,
really
no, go ahead, Miriam.
I really appreciate all the support, and my background is in linguistics, so I'm particularly interested when we're doing this kind of activity, because it kind of like you have to do the semantic, to find out the linguistic, the combination. And I think it will be very interesting how we see those could be applied, like some of the lesson that you share with us could apply for different courses, just like how we can implement CS into different curriculum. I think that's kind of like for the future that also benefit students. But I think teachers do need a lot of training, or this kind of, like community, so we kind of feel comfortable and see, because it's hard for teachers to create their own curriculum when they have to focus on their own curriculum. So it's wonderful to have this community. Thank you.
I wanted to
said it
speak
well.
I wanted to speak to Myra's comment, which was, I agree, but most AI is blocked for my students by the district.
Mhm.
So this is something that we're all going to be dealing with going forward. I was actually just talking in a meeting with people from my district yesterday. And so we've got a few different things here. We have, how can the teachers use it? And I think that that's something that there's nothing like really standing in our way. And the more quickly teachers can get used to it, the more useful it is for them, the better prepared they are with dealing with students using it when they shouldn't. But then there is also this question of the things that are getting blocked for students right now, and the absurdity of this when you're like, oh, that's a bad thing, we're not going to let them use it. Okay, well, they're going to use it at home, right? And I want to teach about, like, okay, let's avoid false knowledge. Like, what are the things we need to look at, epistemic, like, safeguards, things along these lines. I don't know how all that's going to turn out. I know that, AI aside, I get frustrated with my districts with how quickly they block things, because they're so concerned with, we got to keep them safe. And I'm just kind of like, I mean, we don't keep them safe by like shutting it away. So I think this is a battle that is not going to be won quickly. The whole COPPA compliance thing, I don't know how it's going to get resolved, because it's a thing with, when you're talking about generative stuff, how can you be sure ahead of time that nothing offensive can come up? I don't know, but I do think it's something that we have to be aware of, and we have to fight for, and we have to make sure that our districts are aware of the cost of not allowing these things. I will also say that for my AI class specifically, I have my students do parent like sign-offs for things like this at the beginning of the year, and that's how I get around it. But that's not a one-size-fits-all solution, in part because elementary school students are going to be using this stuff. Are they legally allowed to? No, but nothing's going to stop them. So we need to be thinking bigger than that. And I agree, Myra, it's very frustrating, but we just know that this is something that we're all going to be dealing with in our future, and we have to push on the side of reason. The analogy to a calculator, it's more dangerous than a calculator in some ways, but these are still tools that they need to be able to learn in order to be good critical thinking and adroit users of technology in the future. We're schools, it's our job to get them there. Anyway, let me get off my soapbox and make sure that people have a chance to ask questions.
I agree, Matt. I think what we need to do is somehow draft some policy, because admin is still getting their arms around it, right? Because I broached this with my principal in January, right? And she says, just don't talk about it. And I said, message received, but you should think about it because it's not going away.
Yeah. It's a brave new world. Brave new world. All right. Is there anything else that anybody wants to express or anything else that they would like to ask before we call it a day?
May I know this kind of meeting is you continue having it or like this kind of workshop, or I'm interested in learning more. So I would like to know whether it will have this kind of event or continue like sharing or a community of AI educator or some, yeah.
I believe Emily referenced this at the beginning of the workshop, but the AI for AI for CA group has a monthly meeting the first Thursday of the month. I'm very new to the group myself, and unfortunately, my daughter's birthday and my school graduation are both on June 1st, our next scheduled meeting. So I don't know that I'll be able to make it myself, but putting in a plug, I think it's welcome for all. And I think that is a really good place to start for the next hub of folks that are having discussions and trying to do work in this area.
I think
Thank you.
that's absolutely right. And please join. Also, make sure you give the feedback, because while some of it might be about how good a job we did or something along those lines, it's also about what can be done in the future to build up the community, help people out, help people feel more comfortable.
Thanks to you all for giving your Wednesday evening for this, and we're all in this together. Nice to meet you all. Take care until the next time.
All right. Thanks, Paul.
Thank you.
Thank you, Matt.